Okay, so now that we found the slope of the annual sales per year, we can use these same points to help us predict how much the sales are going to be in 2015. So 0.48.9 was one of our points. You could have chosen to use the other point. And then the second point is we know it's 15 years after 2000, but we don't know our y, so I'm just going to call that y. I want you to use this to set up the slope formula. Y2 minus y1 over x2 minus x1. And I have a variable, so I can't simplify, but remember we do know what the slope is equal to. It's equal to 7.4 million per year. So that helps us. I'm going to write it on this side. So we know this, and we can solve for y. The first thing we're going to do is multiply both sides by 15. It will cancel here, and then we're going to add 48.9 over. Multiplied by 15 and got 111, added our 48.9 over and got 159.9. So what we did was we predicted that in 2015 the sales would be 159.9 million. And we had said, of course my graph wasn't straight, but we knew it'd be somewhere between 150 and 180. So that matches with our graph. Okay, so along the slope we have kind of our second concept here, which is parallel and perpendicular lines. Parallel lines, and we've already talked about what those are quite a bit, they have the same slope. Okay, that's the most important thing, same slope. And then you also have this, if they're vertical, they're parallel, because remember, vertical lines have undefined slope. So two vertical lines are always parallel, two horizontal lines are always parallel. The second thing is if they're perpendicular, and there's two ways to think about this. It says they're going to have a product, their slopes are going to be a product of -1. What that means is that they are going to be opposite reciprocals. Sometimes you'll hear negative reciprocals. Okay, but they're so like -2/3, the opposite reciprocal would be flip it and make it negative, so 3/2. Or -3, if I flip it, right, this was -3, which is -3, when I flip it, I get 1/3. Then make it negative. So opposite reciprocals. And then this part's important as well. Vertical and horizontal lines are always perpendicular, like that, right? Okay, so let's use that. Determine whether FG and HJ are parallel, perpendicular, or neither. And then it gets us. So the first thing we have to do is find the two slopes to compare them. So I want you to find the slope of FG and the slope of HJ, and then start by. I calculated the slope of both. Remember I told you to always leave slope in a fraction? Unless it's like a word problem. The one exception is if it's over 1, you can obviously reduce it to an integer. So I have -2/3 and 3. Well, are they the same? Nope. Are they opposite reciprocals? Nope. So they are not. And we are going to graph these 2 points for F and G, and then graph the points for H and J and see what happens. So I want you to plot those 2 points, make a line, plot those 2 points, make a line right now, and then check that. So I graph my 2 points and drew a line, graph my 2 points and drew a line, and I used a straight edge drawing tool in here. You will need to use a straight edge, because if I did it originally kind of softly and they almost look perpendicular, but I knew they weren't because of the slopes. You can see here, you can look at those lines and see that those are not perpendicular, but they do intersect, obviously, because if not, they would have been parallel. So I want you to work this problem and then check back. I got a slope of 1 and -1. And of course, you need to reduce as far as possible. Never leave me something like 6/9. Always get it in simplest form. But 1 and -1, those are almost the same, but they're actually opposite reciprocals, so they're perpendicular. And you can check. Remember, one thing it said was of perpendicular slopes, if you multiply them, you always get -1. But the other was that they're opposite reciprocals. Well, this is 1 over 1. If I flip it and make it negative, I get negative. So those are opposite reciprocals, so the 2 lines are perpendicular. Now we're going to do this, a similar problem, but instead we're going to graph the line that is parallel to MN. So we have these 2 points, and so we need something parallel to it, which means we need the same slope. So the first thing we're going to have to do is find the slope of MN. at negative 3/4. So the slopes of the two parallel lines are the same. So we know this slope is going to be negative 3/4 for our new line as well. And it said to graph it, so we need to start at the point it gave us, which was Q, and then we need to use the slope to move. So we're going to rise, I'm going to go ahead and rise negative 3 and 1, 4. So let's do that. We're going to start at 5, 1, because that is Q, and then we're going to rise a negative 3 and run a positive 4. Okay, well, I run off my graph, no problem. Instead of rising a negative 3 and running 4, let me rise a positive 3 and run a negative 4. So I'm still in line with that, but now I'm just actually on my graph. And again, I do expect you to use a straight edge for your arrows. And now we are finished, and you can practice slopes and parallel and perpendicular.